All right, let's do this. Here we go. Little review from your sophomore year here. Pythagoras, this is all with right triangles. Today and tomorrow, I'm reviewing everything you did with right triangles. Today's a little Pythag. Tomorrow will be, remember SOHCAHTOA? Yeah, we're going to review that, all right, because we need all that for after the quiz. So Pythagorean theorem, let's start. You got to have a right triangle to use it. Got to have a right triangle. Anybody know what the two sides are that connect the right angle, that make the right angle? They have a special name. Not yet, not adjacent. That's tomorrow. Lisa? Well, that's the other side. That's the side across from the right angle. It's called your hypotenuse. Yep. What do you got over there, Tyler?
Is it normally like A and B, like A squared?
Yeah, that's what it's going to be. But I want a name on the diagram. You got two of them. You walk with them. Legs. Hey, there you go. Way to go. Yep, those are legs. All right, the two sides that make up. And Tyler just said it, but here you go. Here's the Pythagorean theorem. A squared plus B squared equals C squared. A and B are, now that we know our vocabulary,
Legs.
Those are our legs, right? It doesn't matter which one is A or B. And then C is our hypotenuse, yes. C is the hypotenuse. It does matter what you plug in there. C's got to be the hypotenuse. Always across from everyone always says the longest side. I don't like that. It's always across from the right angle. All right, can you draw letter A there for me? Got right triangle ABC. Where's my right angle?
C.
C, yep. So does it matter where A and B go? No, just as long as C is the right angle. So make sure we get the diagram right first. And now go ahead and label. AC is 2. BC is 3. Find AB. Now, don't be afraid of the directions here. Find it in simplest radical form because your calculator does that for you already. Okay, so you don't need to be nervous there. All right, need somebody to help me plug in here. A squared plus B squared equals C squared. I tried to pick a basic one right off the bat. Let me know what I plug in for all my letters up there. My good old 3, 5. Here we go.
Isn't maybe 4?
What?
Isn't maybe 4? It's 2, you do 2, 3, 4 thing?
No, sorry, that's 3, 4, 5, Owen. 3, 4, 5. You relax back there, all right? Trying to show off. All right? Stop trying to show off. But it's 3, 4, 5. 3, 4, 5. Felicia, here we go. What should I plug in for A? 2, yep. 2 squared plus, how about your B value? 3 squared equals, you can put an X. I'll keep it C squared because that's what we're looking for. And I'm being serious here. What do you do next?
Add them up. 13.
Find them and add them, right? Find them and add them. 4 plus 9. I'll do this slow here and one step at a time. All right, I get 13 equals C squared. And then how do I get C by itself? Take the what root? Square root, yep. So everyone hit up the calculator right now. I'll do it with you. Calculate square root of 13. Now it says simplest radical form. If it can be broken down, the calculator will show you. See how they just had a decimal there? So it's just my answer is radical 13. That's as simplified as it gets. Now look, if you did something, take a peek up here. If I did something like radical 40, watch. See the difference? It'll simplify it there. All right, so radical 13 couldn't be simplified. So it's just going to stay radical 13. Questions there? All right, how about Laura? Everyone's got a rectangular backyard, huh? Measures 12 by 15. Zach, what class you got now? See, all right, see ya. How long will the walkway be? All right, draw yourself a rectangle. Let's roll. See how this fits in the Pythagorean theorem. Draw yourself a little rectangle. 12 by 15, right? Doesn't matter where the 12 and the 15 go. Diagonal?
Yes.
Yes, I know that's why I read the word. Thanks for the confirmation. Where's it go here? What's a diagonal?
Corner to corner.
Corner to corner, right? Corner to corner. She's going to put a little rock. That's cute. Rock diagonal there. How long will the walkway be? And we're going to round to the nearest tenth now, not simplest radical form. If there's any questions what I'm doing, let me know here. What do I plug in for A and B in this, or maybe C in this problem, right? Just trying to trip you up a little bit here. Who's got this one? Joe, in for A? 15 or 12, doesn't matter. In for B? 12, and we're solving for C. Yeah. Oh boy.
369. I was just helping them out.
Everyone's taking the square root. Notice it said nearest tenth of a foot, so now I have to round my decimal. No radical here. I don't know if it gives you it anyway. So go to your calculator, square root of 369. Does simplify it, but I don't want the 3 radical 41. And this, I know we're not taking the Regents till January, but this is my biggest fear is rounding. That people get rounding correct, because you get off full points if you don't round correctly on that Regents exam. So if I go nearest tenth here, what am I looking at? 19.2. That's it. Right? No extra numbers. Nearest tenth, one number after the decimal. 19.2. Elementary schoolish right there.
Thanks.
Those two problems. You ready to take it up to the big leagues? Big boy, big girl league here. All right, let's do it. Let's bring it up to your algebra 2 level now. Doesn't look like much, right? Right triangle. I got all 3 sides. Not too much bad. Let's find x. All right, let's see what you're made of in here, studs. I want A, B, and C. What are they? What are the A, the B, and the C values so I can plug them in one at a time here. The A, the B, and the C. Let's roll. Boom. Here we go, Amram. Give me one value I can plug in for A. 8 squared. Here we go. Everyone good so far? Give me value to plug in for B then. X minus 4. Now watch. Don't do anything yet. I'm just going to write it. X minus 4 all squared, right? That's what it looks like. Don't do anything to it. Don't try to be a hero. And then what's the C value here, Amram? X. And I'm going to square that. So everyone all right with the plug-in before we do some algebra? There's something that's making me real nervous up there. All right, here we go. 8 squared.
64.
Got it. And here we go. This is where I really get fired up. X minus 4 all squared. No! 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 No. Leave immediately. Absolutely not. Leave immediately. No. Think about it this way. What's, you guys just said 8 squared was 64 pretty quick. How'd you know that? 8 times itself. 10 squared is 100. Why? Because it's 10 times itself. All right? X minus 4 squared is X minus 4 times itself. I got to do some double distribute FOIL right there. Okay, so off to the side. Let's see what you have here. Double distribute FOIL. That is not just taking the 2 and applying it. No, I got to break that habit before January. Who's got this, huh? All I want to know is what did you get with X minus 4 times X minus 4? That's all I want to know. All right, don't get ahead of me. When you do X minus 4 times X minus 4, what did we end up with there? Max, yep, let's roll.
Squared
Okay, I got the X squared, yep.
minus 4x.
Yep.
Minus
minus 4x.
Yep.
plus 16.
There you go, boss. There you go. Good. That's what we should have had when we double distributed FOIL, whatever you called it. All right, can we clean all that up on the left side? All right, let's combine our like terms. So I got x squared. That can't be combined. What else do I have? Negative 4x, negative 4x. Do they cancel?
Nope.
Nope. Negative 8x. And I can also combine the 64 and the 16 to get what?
80.
80, yeah. So far, so good. What's your next move there, bosses? What do you want to do here?
Minus x squared.
Minus what?
X squared.
You want to move the x squareds?
Yeah.
I'm all right with that. We can move the x squareds, and what's going to happen when we do that?
Equals 0.
See ya! They're gone, aren't they? You try to move over an x squared, they're going to cancel each other out. Yep. So negative 8x plus 80. Well, I can't just leave it hanging with nothing there. I got to write something. What happened?
1. No.
1?
0. 0.
0, right? I canceled it out. It's 0, and I'm hoping you guys can solve that now. So the x squared's canceled when I moved it over, and I had 0 on one side. No factoring. Just solve the darn thing for x.
Could you have just
Good idea.
no, it has to equal 0.
You cannot factor x squared minus 8x plus 80. No. It's got to be equal to 0. And when we equal to 0, they cancel, so no more factoring. All right, what'd you get for x when you solved it here? Half 10, yep. Negative 8 equals negative 8x equals negative 80. Divide both sides by negative 8, we get 10. How about that, huh? That's your level right now.
It's pretty
It was.
easy.
How was it?
Yeah.
So everyone go with PyFag.
Yes.
Review number 1 from your geometry days. Ready for review number 2? Some special right triangles that you went over. All right, here's the first one. Draw yourself a right triangle for me. Now see those 2 other degrees that are blank now?
Yep.
45's in for those. A 45, 45, 90 right triangle. All right, there's something special about the sides now.
Both the same.
What are the same? Use your big boy words we used earlier.
Equal.
Opposite.
Lateral.
Equilateral. Opposite.
Everybody, please stop. Please stop. And I'm sorry that some of you won't be able to get that moment back in your life ever again. There are 2 sides that are equal up here. And they're the sides across from the 45s. What do we call those sides again?
Oh, the legs.
Legs, yes. All right, so everybody ready?
Oh,
Number
so the
1
legs are
here.
equal.
The legs are always equal in a 45, 45, 90. All right, legs are equal. And if you need to, you don't have to, but remind yourself where the legs are. Okay, the legs are always equal. Now, how do you find the hypotenuse? And I don't expect you to remember this from 2 years ago. You take hypotenuse. Maybe you will. I shouldn't doubt you guys. I'll start you off. You take the leg. Doesn't matter which one. No, because they're the same. And you multiply that leg by
2.
3.
1
Square root of 3.
by the other leg.
Do something now.
square root
3.
of 2. So if this leg is 5, the hypotenuse will be 5 radical 2. If the leg is 10, the hypotenuse, 10 radical 2. All right, that's how it works. And before we get into the problems, there's one other special. Anybody remember the other special triangle you did? You did 45, 45, 90, and 30,
60.
60, 90. Yeah.
Heck yeah. That's 3 or 4 or 5.
I can't. You think the legs are equal here?
Nope.
Nope. Good job. There are 2 legs though, but watch. I'm going to put a little more detail on them now because they're different lengths. And just instead of calling them leg and leg, the one across from the 30, take a peek. The one across from the 30, I'm going to call the shorter leg. And the one across from the 60, longer leg. How am I ever going to figure out 30 and 60? Which one's the smaller one?
The leg is smaller.
The smaller leg is across from the smaller angle. All right. Good. And this is still the hypotenuse. Here you go. Ready? Hypotenuse. How do you find the hypotenuse length? You take your shorter leg. Can I abbreviate that SL? Is anybody going to freak out? SL. And you multiply it by 2. 2.
Square root of
2. 2.
Are these specifically for 45
Yes.
degrees and 30?
Correct.
So you can't just.
No, correct. That's it.
You probably place it.
And then finally, last rule, so we can start using these bad boys. My longer leg, LL, my longer leg, you take the shorter leg and multiply by
2.
the square root of
2.
no,
3.
3.
I knew it was a square root of 3 somewhere.
It was, yeah, it was somewhere.
Close enough.
All right, so let's use these now. All right, I threw a bunch of rules up there, not expecting you to memorize them yet, so let's use them so it'll come naturally to us. Draw out choice A for me. Right angle at C. A and B can go anywhere. Angle A, 30. BC, I forgot to put C. Side BC is 8. What's AB going to be? First, what type of special triangle are we working with so I know what rules to use?
That's
30.
That's a 30, 60, 90. Perfect. Where's the 8? Is that the shorter or the longer leg so we can identify it?
Shorter.
Why is it the shorter leg?
It's across from the 30.
It's always the shorter leg's always across from 30 degrees. Good. And we're looking for AB. What do I call AB then?
Hypotenuse.
That's the hypotenuse. Everyone with me so far? We're looking for the hypotenuse. So I go to my rule. It says hypotenuse equals shorter leg times 2.
16.
What was my shorter leg we just identified? No, that's an angle measure. That's an angle measure, Owen, right? What's the shorter leg up there? There's only one leg labeled anyway. 8. And you double it. Multiply it by 2, so we get 16. Anything there? 2 more? Cool, I'd love to see this drawing. Ladder leaning up against a wall at a 45-degree angle. It's going to make a right triangle. Let's not be cute here and be artists. All right, it's going to make a right triangle. What's the ladder? Is that a leg or the hypotenuse? It's leaning against the wall. Leaning. That's their hypotenuse. All right, 12-foot ladder. There's your hypotenuse. Leans against the wall at a 45-degree angle. Where are you going to put your 45 if it's leaning against the wall? Not the ground, the wall. Up top or bottom right?
Bottom right.
Top left.
Well, it doesn't really matter, right? Because they're both come out to be 45s. But leaning against the wall's not on the ground. 45 degrees. How far up the wall does it reach? What's the 12 again? Ready? I'll help you guys out. What's the 12?
The ladder.
I know that's the ladder. Is it a leg or the hypotenuse?
Hypotenuse.
Hypotenuse, right? And we're trying to find a what?
Leg.
A leg, right? So let's use the rule I gave you. Hypotenuse, watch how easy this is going to be. Hypotenuse equals leg times radical 2. What's the hypotenuse?
12.
12. Plug it in. Leg. We're trying to find x times radical 2. Now use some algebra skills here. How do I get the x by itself?
Divide by -2 or by square root of 2.
Divide both sides because it's being multiplied. Divide both sides by square root of 12 or square root of 2. You guys are getting to me. And it says final answer in simplest radical form, which I already told you your calculator will give you. What's it give you in simple? No decimals, simplest radical form. 6 radical 2. So that is the questions. You can cross out the next one. I'm not going to have you. You don't need to do something like that. But I am going to warn you before you hit up Delta Math because everyone's going here. Take a quick peek up here because I know this is going to come up in one of the Delta Math problems. Let's see. That's 3 radical 6, 5, and that's, I don't know, I'm going to pick 8. All right. Let's say you had to find that missing side on the Delta Math coming up. First of all, there's no angle measurements, right? So don't assume it's 45, 30, 60. What can I just do that we've already done today?
A squared plus B
This is
squared.
pi fac, right? Now be careful. Hey, take a look. 8 squared plus, what's the other side? 3 radical 5. You have to put all of that in parentheses in your calculator because if you don't, take a look. What's your calculator going to think you're squaring? Yeah, the radical 5, but I need it all. So when you do that today in Delta Math, make sure it's all in parentheses. All right, let's go. Don't waste your time.